Hello friends, I welcome you in lecture number 2 on Laplace transform. In previous lecture we have discussed definition of Laplace transform and we have derived the formula for Laplace transform of exponential function. So we just recall the definition of Laplace transform is Laplace transform of f of t is given by improper integral 0 to infinity e raised to minus st times f of t dt. If this integral is convergent, we say that Laplace transform of f of t exists. And using this definition, we have derived the formula for Laplace transform of e raised to at, and it is given by 1 divided by s minus a, and this is valid whenever s is greater than a. Now today we are going to show that Laplace transform of 1 is 1 by s. Now this we can prove using this formula also. If you observe that if we take this constant a equal to 0, then we will have Laplace transform of e raised to 0 t equal to 1 divided by s minus 0, that is 1 by s, and we know that e raised to 0 is 1. Therefore, Laplace transform of 1 is 1 by s. So this is one way to show that Laplace transform of 1 is 1 by s. You can first prove that Laplace transform of e raised to at is 1 by s minus a, and then by taking a equal to 0, you will obtain Laplace transform of 1 as 1 by s, and because we have a equal to 0, this is valid if s is greater than 0. And if we wish, we can directly prove using definition of Laplace transform. So we try to prove that Laplace transform of 1 is 1 by s by definition of Laplace transform. So by definition, Laplace transform of 1 will be equal to improper integral from 0 to infinity e raised to minus st into 1 integral with respect to t. So we are taking f of t equal to 1 in the definition of Laplace transform. So if you observe that this is improper integral of first kind, so we can write this as limit b tending to infinity integral from 0 to b e raised to minus st dt, and this is easy to integrate. In integral of exponential function is exponential function itself, and we have to divide by coefficient of t, which is minus s here. So integral is e raised to minus st divided by minus s. Limits of t are from 0 to b. So this is going to be limit b tending to infinity. First we take t equal to b, so we have e raised to minus st, and this negative sign we write here, and we have to replace t by b. So e raised to minus s times b divided by s minus lower limit, so minus minus plus, and e raised to 0 t. We put t equal to 0, so we have e raised to 0, that is 1, and we have 1 by s. So this is equal to, now here minus 1 by s is independent of b, so we can rewrite this as limit of e raised to minus s into b as b tending to infinity, plus this 1 by s is independent of b, so its limit is 1 by s as b tending to infinity. Now here we have two possibilities. This coefficient s of b is either positive or negative. So we have this type of situation. If we consider b tending to infinity in e raised to minus sb, we have e raised to minus s into infinity. So this is going to be, if s is positive, we have positive into infinity, that is going to be infinity. If infinity is multiplied by any positive number, we will have positive number into infinity, that is infinity. So this is equal to e raised to minus infinity if s is positive. Now if s is negative, we will have negative number into infinity, that is going to be negative infinity. If s is negative, then s into infinity will be negative infinity, and this is going to be infinite. So we have e raised to infinite if s is negative. Now e raised to minus infinity is 0. We can rewrite e raised to minus infinity as 1 over e raised to infinity, and 1 over e raised to infinity is infinity, that is 0. So we will obtain 0 for this limit if s is positive, and we will obtain infinity if s is negative. So there are two possibilities. If s is positive, s is negative. If s is positive, then this limit becomes 0. So we have 0 plus 1 by s. And if s is negative, this turns out to be infinity. So we have minus 1 by s times infinity plus 1 by s. Now this is infinity is multiplied with minus 1 by s, so that is going to be either infinity or minus infinity. In any sense, this is not going to be a finite number. So limit exists if s is positive, and the Laplace transform is 1 by s. If s is negative, then this quantity is going to be infinite or minus infinite, because we have infinity in the product. Or we can take 1 by s common, and we can have 1 minus infinity. This we can rewrite as 1 minus infinity times 1 by s, and s is negative, so this is going to be infinite, and therefore limit does not exist. So in short, this quantity will never remain finite quantity. So therefore limit does not exist if s is negative. Therefore Laplace transform does not exist if s is negative, and for s positive, Laplace transform is 1 by s. Therefore we have shown that Laplace transform of 1 is 1 by s, provided s is positive. So sometimes they ask you this type of questions: prove that Laplace transform of 1, prove that Laplace transform of 1 is 1 by s using the definition of Laplace transform. So you remember the definition of Laplace transform, and using the methods of evaluating improper integral, we can prove this using the definition of Laplace transform. So here we have shown that Laplace transform of 1 is 1 by s, and if we wish, we can go in this way also. First we prove that Laplace transform of e raised to at is 1 by s minus a, as we have shown in first lecture, and then we can take a equal to 0 in this formula, and we obtain that Laplace transform of 1 is 1 by s. And we can have this type of functions. Suppose I want to find out Laplace transform of e raised to minus 3t, then I can use that formula. Laplace transform of e raised to at is 1 divided by s minus a. So this is equal to 1 divided by s minus coefficient of t, which is minus 3. So 1 minus s minus 3, that is 1 divided by s plus 3. We are interested in the Laplace transform of e raised to t by 2, then this is going to be 1 divided by s minus coefficient of t, which is 1 by 2. So using this formula, we can find out Laplace transform of exponential function. So remember all the formulas which we are going to discuss in earlier lectures. Those formulas are very important. In upcoming lectures, we will discuss Laplace transform of some more standard functions. So this is all about this session. I hope you like it. Thank you very much.